2,000 years ago, people were trying to figure out what things were made of. One idea was that everything was a mix of four basic properties: hot, cold, wet, and dry. If you adjust the right mix of hot and dry, that might make rock. A little less hot and a bit of wet might make wood. The right amount of all four properties might make a leaf. Pure samples of four properties were fire, air, earth, and water. These four substances were thought to be the elements from which everything was made. A table of the ancient elements looked like this. Some people had a different idea about what things were made of. Chemists in the 1800s were busy investigating a lot of different substances. Substances are a type of matter defined by a unique particle. They heated substances as hot as they could. They put acid on them. They ran electric currents through them. Sometimes the substances separated into new substances when they did their experiments. When this happened, they tested the new substances with heat, acid, and electricity. Some of the substances would not change anymore. They called the unchangeable substances elements. Elements are a fundamental substance that cannot be broken into simpler substances by chemical or physical processes. These new elements had different names than the ancient elements. The new elements had names like iron, copper, carbon, oxygen, sulfur, and gold. An element is a fundamental substance that cannot be broken into simpler substances. Fundamental means simple and basic. Elements are the building blocks of matter. Matter is anything that has mass and takes up space. Elements combine to form all the different substances in the world. By the middle of the 1800s, about 60 elements had been discovered. A lot was known about them. Scientists knew some of their chemical properties, such as what other elements they combine with. Chemical properties means a characteristic of a substance that determines how it interacts with other substances. They knew some of their physical properties, such as the weight of standard samples of elements. Physical properties means a characteristic of a substance that can be observed without changing it chemically, such as size, shape, density, and phase. When scientists made a list of the elements, they put them in order by weight, starting with the lightest elements they knew about: hydrogen. The first periodic table. In 1869, a Russian chemist named Dmitry Ivanovich Mendeleev was writing a book about elements. He made a set of element cards. Each card had one element's name and symbol and everything that was known about it. He put the cards in one long row from lightest to heaviest, hydrogen to uranium. Mendeleev looked at the line of element cards and saw something interesting. The first two elements, hydrogen and lithium, had similar chemical properties. As he looked down the line, he noticed that sodium and potassium also had chemical properties similar to hydrogen and lithium. The similar chemical properties showed up periodically in his lineup. Then Mendeleev saw beryllium, magnesium, and calcium all had similar but different properties. The similar chemical properties of beryllium, magnesium, and calcium showed up periodically too. Mendeleev had an idea. He organized the cards into several short rows. This way, the elements with similar properties lined up in columns. The columns are called groups. The periodic reoccurrence of similar chemical properties is why the element table is called the periodic table of elements. When Mendeleev had all the elements laid out, he noticed something was wrong. For instance, the chemical properties of titanium were not like those of aluminum and boron above it. When Mendeleev moved titanium and its neighbors to the right, two things happened. The chemical properties of the elements lined up better, and there was a gap in the table of elements. Mendeleev looked at the gap and predicted that an undiscovered element must fit in that spot. Predicted means to make an accurate estimation of a future event based on knowledge. Furthermore, he predicted the properties that the new element would have. By moving the known elements around so that their properties lined up, Mendeleev predicted about 30 new elements. Over the next 30 years, most of them were discovered. The modern periodic table of elements. The modern periodic table of elements organizes and displays all the elements from simplest to most complex. The periodic table of elements is a way to organize the elements based on atomic number and chemical property. Hydrogen, the simplest element, is number 1. Mendeleev's idea of putting the elements in rows under each other so that the chemical properties are similar in the columns is still used, but Mendeleev didn't know what we know today. There are 2 elements in row 1, 8 elements in rows 2 and 3, 18 elements in row 4 and 5, and 32 elements in rows 6 and 7. This is the modern periodic table. This layout makes the table very long. Often, 28 of the elements are pulled out and shown below the others. Then the table fits better on a standard piece of paper. Color helps to show which elements have similar chemical properties. In the periodic table used in this course, elements that are orange, light blue, light lavender, dark lavender, and yellow-green are metals. Metals are a group of elements that stretch, bend, and conduct heat and electricity. Green, red, yellow, and aqua elements, plus hydrogen, are nonmetals. The green elements on the right are called noble gases. Noble gases are a gaseous element that does not react with other elements. They are interesting because they do not react with other elements.
The periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on t-shirts, coffee mugs, and shower curtains. But the periodic table isn't just another trendy icon. It's a massive slab of human genius, up there with the Taj Mahal, the Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitri Mendeleev, is a bona fide Science Hall of Famer. But why? What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really, that had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their 2-letter symbols arranged in a table. Check out the entry at the 3rd column, 5th row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitri was making a bold statement. He said, and I'm paraphrasing here, "Y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's 1 step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for 1. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It ducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudrin discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is 1 step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, he predicted other elements that were unknown at the time, Scandium, germanium, rhenium. The element he called ecomanganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitri predicted its existence, 30 years after he died. Dmitri died without a Nobel Prize in 1907, but he wound up receiving a much more exclusive honor. In 1955, scientists at UC Berkeley successfully created 17 atoms of a previously undiscovered element. This element filled an empty spot in the periodic table at number 101 and was officially named Mendelevium in 1963. There have been well over 800 Nobel Prize winners, but only 15 scientists have an element named after them. So the next time you stare at a periodic table, whether it's on the wall of a university classroom or on a $5 coffee mug, Dmitri Mendeleev, the architect of the periodic table, will be staring back.